everybody who takes calculus and uses calculus needs to know. But for now, we'll talk about shortcuts. Now, here's how we can think of the first shortcut. I'll give you a way that you can read it and think about it, and then also a formula, okay? For my first shortcut, the way that you might read it or describe it to somebody is that a vertical shift does not change what y prime is, okay? All right. The math, the formula would be something like this. If y was some function f of x, and then you had, let's do like this. Y is f of x and y is f of x plus k, where k is a constant. Then these two things have the same derivative. It's a little bit sloppy for me to define them both in terms of y, but you see what I'm trying to say. This versus this, just in isolation, have the same y prime, as long as that k is a constant. That k is what's responsible for there being a vertical shift. Okay, now I thought rather than talk more about this, I'd show you a little picture. Maybe the picture will help solidify things. And I can pose the lead up to that is, okay, well, why is that true? Why is it true that if you have a curve versus that same curve with a vertical shift up or down, that's what the plus k represents, why do they have the same derivative? If you think about it visually, it's fairly easy to answer. So say that you have a curve like this, all right? It's just a representative picture of a curve. It's no curve in particular. Then y is f of x plus k, well, that would just be this curve, you know, just lifted up. That's what a vertical shift is. It's not to the left or right. You take this curve and its points and you pick them straight up, and that's how you get this one. Well, here's why the derivatives are the same on these. These have the same derivative because whatever the slope is here is going to be the same there. If you take this curve and just, you know, literally pick it up, straight up, you're not changing the slope. This is the slope. You're not making it more or less steep at that point if you just lift it up. And you take another point, like you see the slope right there, it maybe looks about like that. So that's about how steep it is at that point. You know, up here with the curve's vertical shift, it's not really different. It's the same. It's exactly the same, okay? So if you think about it just geometrically, a curve and its vertical shift, well, they're not, you know, at any given x coordinate, they're going to have the same exact slope. And since the derivative tells you the slope of the original curve, that means that these have the same derivative. Okay, it's not hard to show you some examples on that. You know, like for example, if y was x squared, the derivative of that is 2x. But this is that curve with a vertical shift down 4 units. It's going to have the same derivative. It's like x squared plus -4 if you wanted to see it like that. Or even if you didn't know this number, say I had y is x squared plus some number b, and b is some constant. Well, the purpose or the role of that number b is to let there be some kind of vertical shift on that one. Well, it would have the same derivative also. This and this and this have that derivative because they are just vertical shifts of each other. So now that would be true for anything, okay? X to the third power, it happens to be that y prime is 3x squared, but that would be the truth about it if this was x to the third power minus 5. That's a function I just used in one of the other videos. They both have derivative 3x squared. Okay. So that one is not too hard to tell you about. Let's do one more, okay, that may be in the context of this video and the quiz that goes along with it. Could be a little more complicated. So my second shortcut is that if you have y as some function of x that happens to be a straight line, and another way that that might be said to you is linear. Suppose it's linear. Linear comes from the word line, all right? Then y prime will be the slope of the line. It makes sense. And y prime always tells you the slope of y. And so if y is a line, the slope of a line is the same everywhere. The angle of inclination of my pencil is the same at every single spot on it. It doesn't get steeper as you go that way, okay? So y prime just is the slope in the case of y being a line. Okay, so let's take this one as an example. Suppose y equals f of x is a line and it goes through those points. What is y prime? Well, so it's a line, so y prime is whatever the slope of that is. If there's only some way to find it, then, you know, that's what we want. But I remember, maybe you remember too, but I remember learning in algebra that if I have a line and I know 2 points on it, it's possible for me to calculate the slope. Do you remember learning that? Isn't that how you do it? Yeah, that's that y2 minus y1, 10 minus 7 over negative 3 minus 4. So we'll get a slope of, it will be negative 3 over 7. That means y prime is negative 3 over 7. Okay, so what's your derivative? Well, in the case of lines, it's pretty simple. It's just the slope, so we'll say negative 3 over 7, because that is what the slope of that line would be. Okay, now, how is this a shortcut? Well, if, say, you didn't know that about lines, say you didn't know that the derivative of a line is just the slope of that line, then you might approach this one as, well, I need to figure out the equation for the line. Like the equation is y equals mx plus b. And I'd like figure all that out and then realize, oh, it's just m, okay? So we'll just calculate, you know, m right from the beginning, and that's going to be it. Okay, let's look at, I have one last problem that I thought would be good to show you. Okay. The reason I show you this rendition of the one I just showed you is because, I guess I'm thinking about this not only from the perspective of learning to do math, but also science or engineering. If you look in a science book, say physics or chemistry, something highly quantitative, or an engineering book, if say that's the direction that you're going to go, you know, with your schooling, then you'll see lots of constants, but not very many numbers, okay? And you have to learn to work with, say, hypothetical numbers or constants, you know? So when I'm saying like A, B, C, and D are constants, they are fixed numbers. They're not changing, okay? Constants are as opposed to variables. If I say here, well, y and x, they're not constant. They can take many different values. X could be 3, and then y would be 9. X could be negative 4, and then y would be 16. They're not constant. Nothing is restricting x and y, okay? But here, I'm saying A is some unknown but fixed number, and so is B and C and D, okay? So if you've ever taken, say, chemistry, then they'll give you all kinds of constants for different situations, all right? These numbers that are fixed, but maybe not necessarily revealed at all times, okay? Anyway, so, all right, so y equals f of x is this line that's in the picture. And this point, A for x, B for y, I don't know what that is, but I know A and B are constants, and C and D, same thing, I know C and D are constants. What is y prime? Well, this might be more intimidating than the question I just showed you, but it's not any different. Whether I know these numbers or not, they are involved in finding the slope of this line, and therefore, they're all you need to find y prime. It might be frustrating to you that you don't know what those numbers are. You may not like it that you don't know what those numbers are, but it doesn't really matter. This is how it goes. So, okay, y prime is going to be the derivative, and the derivative in this case is the slope of that line. So that would be d minus b over c minus a, right? That's just like your y2 minus y1 over x2 minus x1. I can't take it any further than that without knowing these numbers, so I'll have to leave it there, but that's still appropriate, okay? Now, I show you this just so you can start getting used to this kind of thing. Start getting used to having to work with unspecified constants, okay? Will seem a little strange at first. It's easier to do math in general when all the numbers are known. When they're not, that may make it seem different. It may make it seem more confusing, but just in general, we do the same thing.